All right, hi, welcome back.
Hello. So, this is our new podcast, 6.5 if you're GC.
7.5 if you're Central.
Okay, and today is energy and stoichiometry.
Uh-oh, there's that word again.
Yeah, there's that word again.
We'll get through it.
We'll get through that. So, where does energy go in a chemical reaction? So this is propane right here.
So I've got 3 carbons on that side. We gotta balance this.
First thing, you're right, I didn't write a balanced equation. So let's go ahead and balance this. If I've got 3 carbons, so let's just quickly do CHO, CHO, oops.
Now, if you want to pause this now and try and complete it before we get there, it'd be a great thing to practice.
That's a good idea. I'll quickly do it. This is 3, 8, 2. This is 1, 3, 2. And I see I have 8 hydrogens and 2 hydrogens here, so I'm probably going to need to multiply that. But first I'm going to balance the carbon, so I'm going to put a 3 here. And now I've got 3, I've got, let's see, that's 7 oxygen. Now this is getting hairy. Let's see. I'm going to need 4 hydrogen, which gives me 8. I'm at 3, 4. Oh, I'm getting out of hand here. 10 oxygen. Okay, balance, balance, and I think I need 10 oxygen over here, so I got 5, and I've got 10. So there it is, and you remember we always put a 1 just to symbolize that we've got that. And now this is actually an energy equation. So remind me real quick, this will be your first check for understanding. So if you're new to this, write down CFU1, which means check for understanding.
This is going to be one of those things that we specifically check in class.
For your notes, when we're going around at the beginning of class, this is your check for understanding 1. Tell me, what side does delta H go on? Remember, it's negative here, so pause. What side does delta H go on? Okay. Well, it's negative, so Ms. Morse?
It's going to be exothermic. And if it's exothermic, we're going to go ahead and we're going to write it.
Heat is being released, so it goes on the product side.
Right, or the right side if we're looking at it.
And this is 2200 kilojoules. And it's always positive. Remember, this just tells us what side of the equation goes on. We cannot have a negative energy. So this, guys, is actually a energy equation.
Fabulous.
Let's look at another one. Sodium bicarbonate decomposes, and this actually decomposes into a sodium ion and a
Notice one thing splitting up into 2. Great time to review your
What type of reaction is this?
Decomposition.
This is a decomposition, 2 things falling apart. And my heat of reaction right here looks to be positive. So positive means it is an endothermic. So that means 15.9 kilojoules is going to go on this side. And I keep on doing that.
Now please notice that it's kilojoules per mole. That's going to be really important coming up.
So the good way to look at this, if we look at the last problem, is really we just have 1 mole of propane and 5 moles of oxygen reacting to form 3 moles of carbon dioxide, 4 moles of H2O, and releasing 2200 kilojoules. So this is going to act as my coefficient when I do these equations. So just like this is a coefficient, when we were doing mole-to-mole ratios, we're going to treat this as a coefficient. We're going to treat kilojoules as our chemical. So let's go ahead and do a problem.
All right.
Sample problem 1. This should go in your notes. The value of delta H for the reaction below is positive 88 kilojoules. If the 5.6 grams of calcium carbonate reacts, how much energy is absorbed? So,
before we go any further, I actually do want to see all of those words in your notes, because just having those equations isn't going to make much sense when you review.
That's a good point. So let's figure out, what are we given in this problem? We're given 5.6 grams. So given stands for G. This is what we know. And our target isn't any chemical this time. Our target is actually how much energy.
Now, why isn't it just 88 kilojoules per mole?
It's not just 88 kilojoules because, first of all, let's make sure this is a balanced equation. And let me, before I get ahead of myself, which side of this is positive 88, so this is going to go on this side. And it should be 88 kilojoules. Well, the reason why it's not just 88 kilojoules per mole, it would be 88 kilojoules per mole if I had calcium carbonate, 1 mole of it. But I don't have 1 mole of calcium carbonate. I have 5.6 grams.
Oh.
So let's go ahead and look at this on a separate page. So this was 88 kilojoules plus, and there's a 1 in front of all these, right? This is balanced. Okay, this is balanced. And I am starting with my given, which is 5.6 grams of calcium carbonate. And I'm trying to find energy. So,
the energy that's proportional to 5.6 grams.
Exactly. So we're going to always start with our given, which is 5.6 grams of calcium carbonate. I'll draw my railroad tracks. Okay. Well, before I can do any mole-to-mole ratio, before I can go from moles of calcium carbonate, and now we're not doing moles of a chemical, we're doing moles of energy, if you will.
So a mole-to-mole ratio is going to be a conversion factor where the two things equal each other.
Exactly. So the first thing we need to do is we need to get from grams to moles.
Right.
And so we need to divide by the molar mass.
So if I'm leaving grams, where am I going to put grams? Bottom, right?
Put it on the bottom if I want to cancel it out, or I'm leaving them. And that's 1 mole. I just pulled that out. It is 100 grams. I did that in my head.
Now, if you were to go ahead and do this, this is just calculating the formula mass.
Yep. So I would list out how many calciums I have, how many carbons, and things like that. So grams cancels the grams, and what I'm left with now is moles. So now I can use my conversion factor, which is 1 mole of calcium carbonate, and what's my coefficient here?
88.
It's 88. So I'm going to have, I'm not going to say moles there, I'm going to say 88, and my chemical is at calcium carbonate, it's 88 kilojoules.
All right.
So if I have moles of calcium carbonate and I want to cancel those out, what am I going to put on the bottom?
You're going to put them on the bottom. You're going to put moles of calcium carbonate.
So I'm going to put 1 mole calcium carbonate.
And make sure that you're writing the numbers from your conversion factor, right? Our little equals.
So I just took the 1, and I put it down here. Whatever it's equal to, 88, goes on top. And I'm done. I've got moles, cancel with the moles, and I'm ending with the units which I wanted, which was kilojoules.
Yep, so now you're going to go ahead and multiply everything that's on the top.
Okay.
Go ahead and get that calculator, 5.6 times 88. And then you're going to divide everything by the bottom, so that's 492.8 on top. Divided by 100, we get 4.93.
4.93, and my units are kilojoules. So if I have 5.6 grams of calcium carbonate and it decomposes, this is how much energy is going to be absorbed in the reaction because it's endothermic. Let's look at another one. Sample problem 2. So this is a combustion problem. The value, this doesn't look right. And it looks like you've got the wrong equation up there. Disregard that for now. We'll write the equation. The value of delta H for the combustion of heptane, C7H16, is negative 2145. So this is my heat of reaction.
Now if it's negative, what side does it go on?
It's going to be on the right side.
Exothermic.
It's exothermic. How many grams of carbon dioxide is produced when this much energy is released? So this is going to be a little tricky. First of all, let's write our reaction. And I'll go ahead and do that on the next page. This is combustion, so I know it's C7H16, and it's going to be reacting with oxygen, and it's going to be making
carbon dioxide
and
water.
So this is not balanced. Let's see if I can do it quickly. 7, 8, 14 oxygen, plus 22 oxygen,
So 11.
Did I do that right?
Looks good to me.
Okay, and a 1 goes here. And this was a exothermic reaction, so 2145 goes on the right side. So this is going to be plus 2145 kilojoules. And I'm starting with 1566. So my given is 1566 kilojoules. And I'm trying to find out,
Grams.
what am I trying to find? Grams of
Carbon dioxide.
So I'm trying to figure out grams of CO2. Okay.
You're going to have to follow along with us. It's going to be a little long.
Yes, so I'm going to write a little small. I'm going to start always with my given, 1566 kilojoules. And remember, we are going to treat, draw straight here. We are going to treat this number as my coefficient and kilojoules as my chemical. So if I'm doing a mole-to-mole ratio, or I'm doing a ratio between, let's say it's going to be 2145 kilojoules, which 2145 is my coefficient, and moles of CO2, well, how many moles of CO2 do I have?
Well, in that equation, because it's all equal, 7.
7. So 7 moles of CO2 equals 2145.
So that's our conversion
kilojoules.
factor.
That's my conversion factor, which means I got to put 2145 kilojoules.
Because I want to get rid of kilojoules. I don't need it anymore.
That's why I put it on the bottom. 7 mole of CO2.
Because I know I've got to start seeing carbon dioxide somewhere.
That's right. So now kilojoules is gone, kilojoules is gone. And hopefully, once you've gotten to this point, this is just like we did in Unit 5.
Mm-hmm.
Now you pretend you've got moles of CO2 and you want to get to grams of CO2.
Now, if you still need help with this, we have a couple of videos up.
Mm-hmm.
We'll give you those links in class.
But basically, if you look at your mole map, to go from moles to grams or mass,
Mm-hmm.
you've got to multiply by the molar mass.
Yep, or we can just finish out our railroad tracks.
Yep, which is what we're going to do here. So 1 mole of CO2, and the molar mass of CO2, I'm pretty sure is 44 grams of CO2. And moles cancels with moles, and we're left with the units we want, which is grams. So let's do 1566 times 7 times 44 divided by 2145.
I get 224.9.
200, so I'm going to say 225 grams of CO2. So if this much energy is released, then I can actually figure out how much carbon dioxide is also released, which is 225 grams of CO2. Lots of practice with this, guys. Make sure to bring your check for understanding and CFU 1 in your notes.